Hello students. This knowledge module will cover the remaining concept from the topic of time value of money, which I have not been able to cover in my previous knowledge module. So let's go ahead. The quick recap from the previous video is that we have covered the basic concept of time value of money. So we understood that why it is important and why we want to do it. Then we also understood the relationship between the future value and the present value. We also calculated and used the interest rate to adjust the cash flows both in the forward and backward directions. We understood the concept of compound and simple interest, and we covered two types of annuities, where we discussed that they are the equal payments happening after a fixed interval of time, and we calculated their future values. So in this video, we'll start with the present value of the annuities, how to calculate it. We'll also look into the concept of perpetuity and the difference between the simple or quoted interest rate and the effective interest rate. And finally, we'll finish this knowledge module with the amortization table. First of all, what is the amortization, and how we basically prepare our amortization table and do its calculations. So coming back to the annuities, the ordinary annuities is the equal payments happening at the end of every period rather at the start of every period. And in the previous knowledge module, I calculated the future value of the annuities. Over here we'll see that how to do the present value of annuity. And let's start with the ordinary annuity first. Let's suppose if there is an annuity and there is a person who came to you and said that for next 3 years, by the end of every year, we will pay you back $400 at 5% interest rate. So it means he is trying to get some money today from you, which over the next 3 years will grow at 5%, and you'll keep getting the equal amount of payment. So this is not a lump sum payment, it's an annuity. So you want to know that what is the present worth of this annuity. So it's very simple. Whatever is the first payment over here, this one 400, discount it back to right now. This is the payment you will receive at the end of the first year. So discount it right now. You will find that its present worth today at the end of the year zero. Remember, end of the year zero means today, right? It's $380.95. What you have done, you simply have discounted it one period back, and when we discount it, we actually divide the payment 400 divided by 1 plus the interest rate. Remember, 5% in decimal, it's 0.05, right? So this is 380.95. Likewise, for the second payment 400, which you will receive at the end of the second year, over here the period is year. So its present worth is 1 divided by 1.05 raised to the power 2. You discounted it 2 periods back. So the present worth of this 400, which you will receive after 2 years, is 362.81. In other ways, this 362.81, if you deposit today, after 2 years, it will basically give you 400 at the rate of 5%. So 5% interest will be added to it over the 2 years period of time. The present value of the third cash flow, not cash flow, I want to say payment, because it's the equal payment of the annuity, is 345.54, and you discounted it, means you divided it with the interest rate over 3 periods. Raised to the power 3 is suggesting you that you discounted it first to the second period, first period, and then right now. So if you add them all together, 380.95, 362.81, and 345.54, it is 1089. So if a person will come and say, might be he's an agent firm and selling the product of any financial institution to you, and saying that, okay, get 400 in equal payments over the next 3 years, where you will be earning the 5% interest. In other words, he's saying you that, okay, give me 1089.30, and then At 5% in equal payments, we will this product will give you back $400, right? Then this is again, if you have a lot of time period, this is a very time consuming exercise to find the value of each payment individually. So that's why I would recommend you to use the financial calculator, and I use the BA2 Texas Instrument BA2 plus calculator. And if you do over here, you can see how I will do it. What was the N? So N was 3 years, 3 periods. In fact, again, the period can be anything. It can be years, it can be months, but over here it's basically the years. So now it is clearly written over here beginning. I need to check how the annuity is set in the calculator. It is set at the beginning, means it's for the annuity due. I have to change it to the ordinary annuity. So second enter. Now it will change it to the ordinary annuity. So what is the time period? 3. And what is the interest? 5%. Over here I'll not use the decimals, I'll use in terms of percentage, 5%. What is my present value? This is what I want to find. What is my payment? It is $400, and because I'm assuming that I will receive it, then it is plus. And what is the future value? Apart from these 400, is there any future value over here at the end of the third period? No. So 0. And compute the present value. This is the same what we got over here, right? So 1089.30, right? Now with the formula, this is the formula. If you do not have the financial calculator, you can use this formula, where PMT is the payment, 400. 1 minus 1 divided by 1 plus R. R is the interest rate. Some books use I, some books use R. You can change it. You can interchangeably use I and R. Both are representing the interest rate. And raised to the power n. So what was the R? It was 5%. So in decimals, 5% is 0.05. So you will use the 0.05 over here in R, and likewise also in the denominator over here, 0.05. What is n? It is 3 time periods. So it will be used. It will be 3, right? So if you plug that number, you will get 1089.30. With the calculator, I have just shown you that how you can compute it. You need to feed n in 3 in n, 5 in the interest rate over here, per period interest rate. PMT is 400 and future value is 0, and now your value will be 1089. So if you will deposit 1089 and 30 cents today at 5% interest rate, compounded annually, means interest will be paid each year. You will keep receiving 400 after every year, over the 3-year period of time. And this 400 will obviously having a part of the principal plus the interest which has been added into it. Now, what about the annuity due? So the only difference between the ordinary annuity and annuity due is, in annuity due, the payments are happening at the beginning of the period. So what is the worth of 400 which you will receive today? So it's sort of a very weird example where the person is coming to you and saying that I will pay you 400 in 3 equal installments, and 400, one payment of that installment you will receive right now, and you need to deposit us something. It's sort of a weird, but you need to understand it in order to understand that how the annuity due payments are calculated. So 400 if you will receive today, 400 at the beginning of the year 0 means right now, 400 at the beginning of the year 1, 400 at the beginning of year 2, at the beginning of year at the beginning of year 3, actually, not 2. So this first 400 is at the beginning of year 1. This 400, the second one, is at the beginning of year 2, and the third one is at the beginning of year 3. Remember, this is the end of the year 2, which is the same as the beginning of the year 3, right? So then after that you will not receive any payment, and this financial product is only offering you these annuity due payments for 3-year period of time. So the first 400, what is the worth of the 400 which you will receive right away from that financial product? It's 400, because it has not been discounted anything back. So this is 400, so you'll get 400 back over here. So 400 divided by 1.05 raised to the power 1 multiply by 1.05. So you cancel the denominator or the numerator. If you are confused about this calculation, simply remember that this 1 raised to the power 1 is 0. So anything 400 divided by 1.05 raised to the power 0, if someone has a power of 0, it's actually equal to 1. It's basically simple mathematical concept, basic mathematical concept. So the first 400 will not be discounted. Like if you have holding a $400 in your hand right now, and I'm coming to you and asking what is the worth of this 400, so you will say, oh, what's up, like crappy sort of a question it is. It's the value of this 400 is 400. Then yes, it's 400. Then what is the value of the 400 you will receive at the beginning of the second time period over here, or in other words, at the end of the first time period? Its value is, you have to discount it back. At 5% rate, it's 380.95. What is the value of the third cash flow, third payment of the same annuity due? It's 400 divided by the 2 discount period, because this 400 is happening at the start of the third time period, because annuity due has this characteristics where the payments are happening at the start or beginning of each time period. So 400 divided by 1.05 raised to the power 2. So 2 periods back, right? So you will receive 362.81. And now if you add all of these present values of these individual cash flows, what is the present value of the annuity due? 1143.76. And you can see that you need to deposit more today compared to the ordinary annuity, and which intuitively is right, because you are receiving the first payment upfront this very same day when you will deposit 1143.76. How to do it on the calculator again? So you're in the calculator, first of all, you have to change the payment mode to the beginning by pressing second enter. Now you are set to go and you're good to go. N is your 3, same 3. Interest is your 5, and your present value, this is what you need to find. So that's why we will press this button in the end. What is the payment? It's 400, so which you will receive, so plus, and there is no future payment. So all these are the part of the annuity, they are the fixed payments, right? So there is no lump sum payment happening in the end. So 0 is the future value. Compute present value 1143.76. so this is the same what you're getting over here, right? With the formula, this is the formula for the present value of the annuity. So if you plug the number over here in R 0.05 raised to the power, what is N? N is your number of time period 3. And why we are multiplying it 1 plus R over here? The reason is that every payment over here is getting discounted by 1 less period. So if you remember, in the ordinary annuity, this 400 was over here, the second 400 was over here, and this third 400 was in the end, right? So over there in the ordinary annuity, all the payments are getting discounted by 1 more time period, right? Over here, 1 less time period. So every payment is getting discounted by 1 less time period in annuity due compared to the ordinary annuity. And in order to capture that effect, you have to multiply the same ordinary annuity formula with 1 plus the interest rate, or R or I, interchangeably you can use that, right? And I also have done and have already shown you how to do it on the calculator. Now the perpetuity, it's a very interesting concept, and sometimes students might wonder that what does it mean, and does it really happen? If a person comes to you and say that, okay, you will keep receiving $50 at the end of every period, and the annual interest rate, assume that this payment, $50 interest payment, is at the end of every period, and you will receive it forever. 50, 50, 50. So if someone is getting some, obviously if an agent from a financial institution come to me and trying to sell me the financial product, and he is offering me to get the $50 at the end of every year forever, right? And he will is also offering me some interest rate. So obviously at right now he wants some deposit for me to make, right? So for me to make that deposit, if I want to find its value, all I need to divide that equal payments, which I will receive forever, by the interest rate which he's offering me. So if there is a person who's coming to me and saying that, okay, we'll give you $50 at the end of every period, and the interest of the period is say 10%, right? So I will simply divide 50 divided by 0.1, because 10% is 0.1 in decimals. So it means the worth of that investment to me is 500. And this formula is actually have driven off from the formula of the present value of the ordinary annuity. If you see what is the present value of the ordinary annuity, this one over here, if n is very long, my investment period is approaching infinite, right? To the infinity. So this is infinity over here. So my denominator is very big over here. 1 plus r raised to the power n is so big that if I'll divide 1 by such a big denominator, this term 1 divided by 1 plus r raised to the power n is almost approaching to 0, right? So in the numerator, I'll get 1 minus 0, which is actually the 1. So PMT into 1 divided by R becomes PMT divided by R. So from here, the formula of the perpetuity is derived. So it has derived from that formula. So PMT 1 divided by R. And if you want to see the practical example of that, so read about the console, which were the bonds issued by the UK government in order to fund their wars. So they were so much indulged in the war against French that they, in order to meet their expenses, they had to issue such bonds where they promised to pay the coupon payments or the interest payments forever into the future. And the value of such was that, so that is actually the perpetuity. So in case of perpetuity, it's sort of an annuity, but in annuity there is a specific time period, but the perpetuity, there is no time period. You'll keep receiving the payments, same payments, forever after equal interval of time. So after 1 year, say $50, then $50 after a year, then $50 after a year, divided by whatever is the interest rate. So the console, those bonds are called console, which were issued by the UK government. And if you go into the following link, which is mentioned on this slide, you can read about that. But that was the practical example of the perpetuity. So the present value of such perpetuity or such constant cash flow, which will happen forever, is simply the equal payments, PMT, divided by the interest rate. If you compute it, that will give you the present value of the perpetuity. So for example, if someone will come and try to sell you a product where you'll keep receiving $100 at the end of every period, and the period interest rate is 5%, right? The worth of such perpetuity, the worth of such perpetuity is actually the $2,000. In case of second one, if another person comes and saying you that, okay, give us, we will pay you $100 forever, and the interest rate which we are offering you is 10%. The present value of that perpetuity is 1,000. Now try to understand the relationship over here. Given the constant payments, equal payments, 100 and 100 over here, if the interest rate will increase, right, the present value will decrease. So from 5% when it increased to 10%, right, so the present value decreased from 2,000 to 1,000. And this is a very important relationship. So this relationship is suggesting you that when you have a small interest, then it means that because you are discounting these $100, right? So when you are discounting it with a small value, the answer, which is the present value, it will increase. Likewise, if the denominator will increase, obviously the present value will basically decrease, right? So this is an important concept to remember, especially when we will go to any future calculations where we will increase or decrease the discount rate, through which we will try to find the present value of any future cash flow. Always remember, whenever in the denominator the rate of return or the discount rate, it will increase, the value of the cash flow today will decrease, and vice versa. Means when it will increase, when it will decrease, the present value will increase, and when the discount rate in the denominator will increase, the present value will decrease. So they always move in the opposite direction. So again, you can double check this thing with 2%. So say if another person comes and say, we will pay you $100 forever after a fixed interval of time, after, and the per period interest is 2%. So divide 100 with 0.02. So pause the video over here. What is your guess now? Because from 5% the interest has decreased, then the present value should increase. And yes, the at 2%, the $100 if you will receive forever, then the present value of such perpetuity is 5,000. You can do it with the calculator by pausing the video over here. Now, two sort of payments we have already discussed, and in fact I also have briefly discussed in one of the previous videos what are the uneven cash flows. So if you have uneven cash flows, there is no formula for that, and you can use the calculator. For example, if you have 400, 300, 250, so it's not an annuity. These are the uneven cash flows. This is not also single lump sum payment. These are three different or unequal cash flows. So you individually discount them and find their value. You add them together, you have 869, right? Now look over here. So it means that there is no single formula. You have to do it individually and simply add them together. That will give you the present value of the unequal cash flows, right? So this is the calculation for calculating these cash flows, unequal cash flows. Now let's go and check this unequal cash flow timeline. So maybe you are thinking to receive these cash flows after the end of 6 time periods. So after first time period, or after 1 year, let's come to the years again, you want to get 400, you want to again get 400 at the end of the second year, 400 at the end of the third year, 400 at the end of the fourth year, 300 at the end of the fifth year, and 250 at the end of the sixth year, right? It could be any reason, right? Might be it is actually you are imagining. Let's suppose if I will be receiving this. So what is the value I should deposit in my account right now? And if that account is giving you a guarantee to have the interest rate of 6%, so the account is giving you guaranteed 6% interest rate. So you will wonder, what should be the present value of all these future cash flows which I should deposit today in the bank, so that I'll be able to withdraw this 400, 400, 400, 400 at the end of first, second, third, and fourth period respectively, then 300 at the end of the fifth time period, and 250 at the end of the sixth time period. Over here I'm taking the period on yearly basis, right? So now the first cash flow is 0, right? What is the the cash flow at the end of the 0 time period? This is the end of the 0 time period, it's 0. The cash flow, the first unique cash flow is 400, right? Is it an annuity? No, it's not an annuity. For the annuity, you need to also have 400 at the end of the fifth period and 400 again at the end of the sixth period, right? So this is not an annuity. So we have to treat it as an unequal cash flows, right? Uneven cash flows. So the first 400, you consider them as a first unique cash flow. So you will press in C01, 400, but it happens 4 times. 1, 2, 3, 4. So the frequency of these cash flows in your financial calculator, I'm explaining you the financial calculator, how to do it in BA2, Texas Instrument BA2 financial calculator. So the frequency is 4. Then the second unique cash flow is 300, and the frequency is only 1 because it only appeared one time. If it would have appeared 2 times, then you have to press the frequency as 2, right? Then the third unique cash flow is 250. So the C, it is not CF3, it is C03, right? So let's change it very quickly over here. So C003, right? So this is 250. And what is the frequency? By default frequency is F031. And then if you compute it by pressing the interest and finding the net present value, you will get 1756.5, right? If you want to do it by hand, again, it's a very time consuming exercise. You have to divide this 400 with 1 plus the interest rate, which is 0.06, because 6% is the interest rate. But you have to write in the formula, when you are using the formula, in decimal form, raised to the power 1, because it will discount back by 1 period. What about this? 1 plus the interest rate discounted by 2 time periods, means 400 divided by 1 plus 0.06 raised to the power 2. What about this? 400 divided by 1 plus 0.06 raised to the power 6, and so on and so forth, like for this, this, and this. And once you have the present value of each of these individual cash flows, add them together, you will get 1786.5. But if you have a financial calculator, why to waste so much time calculating these cash flows individually and then adding them up, right? So I'm going ahead and using the financial calculator. So look over here. I'll go into the second cash flow and then always clear the register, so that if there is any calculation from the previous question, that must get cleared out, right? Now, what is my cash flow at the start of the 0 time period? Means right now 0, right? So 0, I'll press over here, enter, go down. What is my first unique cash flow? 400. Over here, minus plus does not matter, right? So if you will feed in the number in plus, it will come as plus. If you'll feed in minus, it will come as minus. So there might be some calculation where it matters when the concept of the capital budgeting comes, and we will discuss those things when that chapter or that topic will come. So 400, enter, first unique cash flow. How many times 400 appeared? 4 times. So frequency is 4. Enter. What is the second unique cash flows? 300. Enter. And how many times it comes? 1. So by default, it's already 1. Does not matter if you enter or you simply go down. Only the 1 is already there, right? So now the third cash flow, C0 unique cash flow. So 250. Enter. And how many times it appeared? Only 1 time. By default, it is already 1. So we are good to go with further, we are good to go to enter the interest rate. If the 250 has appeared more than once, then yes, you have to press 2 and press enter. If it is 1 is the default value of the frequency, so it is not necessary to press the enter. Now go into the NPV button. Press 6, not 0.06, 6. Enter and compute. Is this the same thing? 1786.46, not 50. It's 46. Just let me change. 46, right? So this is 0.46. Now, this is how you find the present value. Net present value just gives you the present value of these uneven cash flows. But what about the future value over here at the end of the 6th period? One way is, if you're in your calculator, you have net future value, you simply do the computation, you will get all the values of these cash flows at the end of the 6th period, right? But if you do not have this button, which basic calculator don't have, then do it manually. What do? You multiply this 1 plus 1786.46, which is the present value of all these future cash flows, and manually through the formula compound it, not discount it. We are adding the interest. When we add the interest, we call it compounding. And whenever we do compounding, we multiply with the interest rate. In discounting, when we try to find the present value, we divide with the interest rate. So you have to compound it over the 6 period of time. So 1786.46 multiplied by 1 plus the interest rate 0.06 raised to the power 6, because there are 6 period, 1, 2, 3, 4, 5, 6, right? So if you do the calculation, you will find 253,413, which is the same over here when if I'll be using the calculator to find the net future value. So this is how you do the computation when you have uneven cash flows, right? Now it's important to understand, if this is the data given to you, that $700 is the present value, means there is some amount which you are going to deposit today in the bank, and the bank is giving you the guaranteed 10% interest rate over the next 3 years period of time. So obviously the future value of this 700 will be 931.70. So if a person will tell you that there are two investment alternatives, one, you will get 700 like today, and in the other one you will get 900 if you deposit the, let's suppose you in, like, it's more easy that you won a prize, and in that prize you are getting 700 either today or 931.7, and the bank is offering you the 10% interest rate over the next 3 years, right? So what is the situation? You won a prize. In that prize, you are getting 700 today, right? And the other option is you can get 931.7 after 3 years. Now the bank is offering you 10% interest rate for 3 years period. So with which option you will go? You will actually be indifferent, because both of these options are, remember that 10% interest rate is guaranteed interest rate. So both of these options are equal to you. You are not able to make or differentiate between these two options, because none is better for you, right? So 931.7, which you will accept, right, it will give you the money after 3 years, right? That's the prize money. The other was to get 700 today, but your bank is offering you 10% also over the next 3 years. So you'll deposit that 700 in the bank and have that money grown to 931 over the 3 year period of time at 10%, right? So you will end up getting the same 931.7 which the other prize money is or prize option is offering you, to get 931.7 after 3 years, right? So you will remain indifferent. So you will not get bothered about it. Now, how to solve the interest rate? It's very easy with the financial calculator rather with the formula. So I'll only from here onward keep using the financial calculator. So suppose you have 78.35 and you want to invest today, and after 5 years you will get $100. So what interest, annual interest you actually earned? So you simply will plug in 5 for n. For the interest rate, you are not going to plug, because this is what you need to find. Present value you plug in minus 78.35. Payment is 0, because these are not equal payments. It's only we are dealing in lump sum payment. So future value is 100. So the interest rate is 5%. Let me quickly do it for you over here in the calculator. So your n is 5. Your investment is minus 78.35. There are no annuities involved. The future value is 100. Compute what is my interest which I earned is 5% over here, right? Now in another question, let's suppose if you have 68.3 and this is what you are actually investing at 10%, and you want to withdraw this amount when it becomes equal to 100. So you want to know that what is that time period in which this $68 will be converted into 100. So 68.3 minus is the present value What is your N? This is what you need to find. Whatever you need to find, you have to press it in the end. What is the interest? 10% interest. Your bank might be giving you a guaranteed 10% interest, right? What is the payment over here? There is a zero payment over here. So what you will get, you want to get $100 future value. Now you want to know that in how much time period you'll able to convert $68.3 investment into $100 if the investment is earning 10% interest rate. So compute, and this is giving me 4 time periods. So 4 years. In 4 years, you'll be able to convert this amount, $68, into $100, right? So this is over here. Now, up till this time, mostly we assumed the investments giving you the return over a year, right? But there are different compounding also. So when there is interest is being paid only once a year, we call it the annual compounding. But there are many bonds which actually give you the return or the interest payments on semi-annual basis, like after every 6 months. So we need to understand about those concepts. So when the interest is being paid more than once in a year, right? Let's suppose if it is getting paid 2 times in a year, so we call it semi-annual compounding. If it is giving you the interest after every 3 months, we will call it quarterly compounding. If it is giving you the interest after every month, we will say that it's monthly compounded, right? So it means interest is being paid 12 times in a year after every month, right? So annual compounding is the process of determining the future value of a cash flow or series of cash flow when the interest is being earned only once per year. But in semi-annual compounding, let's start with the semi-annual compounding, and we'll basically use the same concept for the quarterly compounding and monthly compounding, or even daily compounding. So in semi-annual compounding, the interest is being paid twice a year after every 6 months. So you deposit some money, and after 6 months, you'll earn the interest. And then after further 6 months, you will get the second interest. Remember, for the second period, the interest earned in the first period is already accumulated in your initial principal. So it means for the second period, you have more amount on which you will be earning the interest, right? So the future value of the lump sum is always large if the interest is compounded more frequently. Obviously, that is very intuitive. If you start earning interest more frequently, and that interest has now the opportunity to earn the interest for you in the subsequent periods, obviously you will actually end up getting more lump sum future value compared to a situation where the interest is only being added once a year, right? So we have a few concepts about interest rate now. There is a simple interest, which is the quoted interest, and it is used to compute the interest paid per period. So it is simple interest. Then the annual percentage, remember over there that per period over here, what we are considering is annual up till this time. So annual percentage return is basically the same simple interest rate. But we have to convert this simple interest into a per period interest if we have if the interest is being paid more than one time in a year. And we will see with some calculation in the next slide. Then there is also an interest of the effective annual rate. Let me try to explain you over here about the effective annual rate with an example. So for example, you have a present value of $100, means this is what you are going to deposit today in a bank, and you want to deposit it for a year. Now the bank is giving you a simple return, which is giving you, in other words, it's an annual return of 10%. So this 10% is the annual return, or also we'll say it APR, annual percentage return, annual percentage rate, and also we'll call it the quoted rate. So the quoted rate is 10%, but its compounding is on the semi-annual term basis. So it is getting compounded semi-annually. So means the interest will be paid on this $100 twice a year, means after every 6 months, right? So the person has the opportunity to interest more frequently, 2 times in a year. So interest will be paid 2 times in a year. So we have to first convert into a per period interest. So what is the semi-annual compounding? How many times interest will be paid over here? 2, right? So you have to divide the simple interest or the APR, annual percentage rate, by 2. So 10% by 2 is 5%. So every period, so it means the whole year is divided into 2 periods. 2 periods of 6 months each. And we have to do it because now here the compounding is not annual. The compounding is semi-annual. So the interest will be paid 2 times in a year, right? So 2 times in a year means that a year can be divided into 2 halves, 6 months and 6 months, right? So after 6 months, the $100 will be converted into, at 5%, $105. And why we got this 5%? You will only be able to get it by dividing it, the simple or annual rate, with the number of compounding, or number of times interest will be paid. So 2 times interest will be paid. So that's why it's 5%. So $100 after 6 months becomes $105. 100 into 1 plus 0.05. So remember, it is raised to the power 1 over here, right? Now what happens in the next one time period, right? So the 105 will be calculated as 105 into 1 plus 0.05, which will be equals to 110.25%. If the return would have been paid only one time in a year, what would have been the value of $100 which you have invested? 110 only. So 110.25 is more than 110. It means that the effective, now I'm not talking about simple, effective interest rate is higher. You did not get 10%. At 10%, the value would have been 110 of the $100 which you have invested. With semi-annual compounding, the 100 actually got converted into 110.25. And what is the rate which you got? You actually got 10.25%. So the effective EAR stands for effective annual return. So when you have the annual compounding, the simple return interest rate, right, R simple, is equal to the REAR. So the simple interest rate is equal to the effective interest rate when the compounding is when the interest is being paid 1 time in a year, when there is an annual compounding. When the compounding is more than 1 time, means it's a semi-annual compounding or quarterly compounding, or you can say daily compounding or monthly compounding, your effective rate of return or effective interest rate is always more than the simple interest rate, like in this case, because the interest is being paid 2 times in a year. So 10.25. So in other words, effective interest rate, or REAR, which we symbolize the effective interest rate with REAR. This is the rate which you will get as if the interest is being paid to you once a year, right? Like, for example, if you disregard the semi-annual compounding over here, how you will be able to reach from $100 in a year to 110.25 over here? By multiplying this $100 with 1 plus this rate, 0.1025 raised to the power 1, right? So you will be able to convert this $100 into 110.25. So if you have the different investment alternatives which are giving you the payments or lump sum payments at, or in fact which are giving you the interest rate with different which are giving you the interest with different frequency. Means one might be giving you the interest with semi-annual compounding, another is giving you the interest with, say, the monthly compounding. The only way to compare those two or three alternatives is to find their EARs, like the effective interest rate, effective annual interest rate, and then you will be able to, whatever alternative is giving you the highest value, that is the most beneficial investment for you. So again, R simple is usually written in the contracts. For example, if you'll go into to finance a car, mostly they will write the simple interest rate over there, that okay, so our annual interest rate is 4%, we'll charge you 4%. But because this is the annual one, but because they will be getting the installment payments after every 1 month, or maybe after every 15 days or every 2 weeks, it means that the frequency of getting the payment from you is more than one time in a year. So their effective interest rate which they are charging from you is actually more than the simple interest rate. So this is very important concept to understand. You are actually not paying simply the 4% which is written in the contract. You are actually giving you are actually giving them more than 4%. So then there is also R per, interest per period, and this is also an important concept. So these rates which have been given to you, these are on annual term basis, right? Like over here, 10%. But in order to do the computations, you have to consider what is the compounding, how many time interest will be paid to you, and accordingly you have to convert into the per period interest rate, like what I have done in this example. I converted 10% by dividing 10% by 2, so I got 5%. Now the 5% is my per period interest rate. Per period interest we actually use for the calculation, both whether we are using the formula or the financial calculator or even in the Excel. So per period eventually will be used. So if the compounding is annual, then you keep using the 10% because your simple R is equal to the per period R. You keep using this 10%. What if your compounding is quarterly? Then quarter means there are 4 quarters in a year. So 10% divided by 4, 4 times the interest will be paid. So 10% divided by 4, you will get 2.5%. So your per period interest is 2.5%. So after every period, the interest will be paid to you on your principal at 2.5%, right? But if you add up 2.5% for the whole year, your simple interest will come, which is 10%. This is an important concept to understand. So look over here. Now, if the simple interest rate is 8% with compounded quarterly, so this is 8%. Now, what is the how many times the interest will be paid in a year, right? So if the interest is compounded quarterly, means 4 times interest will be paid, right? So simple has to be divided by the periods per year, right? So how many periods are there? 4, right? Quarterly means 4. So 8% is the simple interest rate. 8 divided by 4, 2%. 2% is the per period interest, and we will use the 2% means per period interest in the calculation. And likewise for the 8%, if the compounding is done on a daily basis where the interest is being paid on daily basis, then the per period interest is 8% divided by 365, and we will use the per period interest to do our calculations. Yes, over here you can see the simple interest rate is 8%, per period interest rate by dividing it with the frequency of compounding, or how many times the interest will be paid in a year, we got 2%. Like for the daily compounding we got it's a monthly compounding. For monthly compounding we got 0.667% if it's a monthly compounding. Now, in order to convert to a effective annual rate, which I I earlier mentioned, it's very important, because if there are different investment alternatives, you need to find out the EAR for each of them in order to understand which is giving you the most return, and where the investment alternative which is giving you the highest EAR, the effective annual interest rate, that is the best for you to do the investment. So 1 plus the simple interest rate divided by the M, which is the number of times interest will be paid to you, or compounding, the interest is getting compounded, is M. So if if you want to know what is the return which the car financing company is charging from you, say if they are charging 4% to you, then you simply divide 4 with 12, because if you are paying the interest payment 12 times in a year, and then raised to the power 12 over here minus 1. So let's see an example over here. If there is a investment that pays you 12% interest, and you will get the interest 12 times in a year, right? So the simple interest is 12%, which is 0.12 divided by 12, because it's the interest is getting it is getting compounded monthly, right? So it's 12. If it is getting compounded quarterly, then M is 4. Then you have to write 4 instead of 12, and then it is raised to the power 12 in this case minus 1. So it will give you 0.1268 if you do the calculation, and in terms of percentage it is giving you 12.68%. So on the face of it, you can see that you are just getting 12%, but because you are getting more frequently the interest after every month, so after first month the interest whatever you will get, that now becomes the part of the principal for the second period, means second month. Over here periods are month, because the compounding is the interest is basically compounded monthly. For the third period, now you have whatever the interest you have earned in the first period and second period, it will be added to your initial investment. So that becomes the principal in order to do your have the interest calculation for the third period, and so on and so forth. So that's why if you are investing $100 at 10%, you, instead of getting 100 so $100, so it means instead of getting $112 after a year, you will get more than that. So you will get actually this much interest rate, 12.68%. And you can pause the video over here and do your own calculations. You simply multiply 100 with 1 plus 0.1268, and you will see that you will get actually more than $112. And this additional thing is, or additional amount is, because of the frequent compounding rather than the only one-time compounding or an opportunity to interest in a year. Now let's move to the amortized loan. What are the amortized loan? So amortized loan are like for the house loans or the car financing loans, auto loans, which we say, where you have to pay back those loans over the life of the loan in equal amount over a fixed interval of time. So for example, like I have taken the loan for my house, and after every 1 month I have to do certain payment, right? And over the life of the loan, I have to keep doing these payments, and by paying the equal payments, I will eventually, once the life of this loan will over, I'll end up paying the whole loan amount, right? So this is basically the amortized loan. Now when I pay every payment, in every payment there are two portions. One is the principal, so I pay back some of the principal which I have borrowed from the bank, and some interest which is basically getting charged, and that interest is actually the bank's profit, because principal is simply what they have lent to me, they are getting back. The other portion is my is their actual profit, which is basically my cost. I am getting charged with that interest amount, right? So those are the amortized payment, and the calculation is very easy to find out that how to find the equal payment. So look over here. Let's suppose if you have taken, this is a very simple example. If you have taken a loan of 33,000 and the lender is charging you 6.5% from you and annually. So this 6.5% is the annual charge from you on the yearly term basis. And I'm keeping the calculation very easy. Rather paying every month, say you have to pay after a year. So after 1 year, then after some part after second year, and after third years. That's why I've written a year over here. So you borrowed 33,000 right now over here. Then after 1 year, you agree to pay the amount. Then after at the end of the second year and at the end of the third year, you want to pay the amount. And PMT is actually always the equal amount. So you clearly see that it is sort of an annuity. Can't you see that? It's a fixed payment which you have to make, and that fixed payment is happening after fixed interval of time, right? Same payment after fixed interval of time. So it's annuity. It's like, it's not a rocket science. Now by this time you have the concept of the annuity, right? And this is also the, which sort of annuity? Is it an ordinary annuity or annuity due? It's ordinary annuity. It's happening, the payments are happening at the end of every period rather at the start of every period, right? And this is what I was saying, that why it's ordinary annuity, because its name is ordinary, because usually this happens more frequently when businesses, you do the transactions in your transaction and avail most of the product from the bank, or even when the businesses deal with each other, right? So let's start with the calculator. It's very easy. Let's first go to the same slide over here. So what's happening over here? First of all, I have to change this beginning to the end, because this is an ordinary annuity. Second payment, second, enter. So now I'm good to go. What is my N? This is 3 time period. Remember, over here it's on a yearly basis. So 3 N. What is the interest rate the person is charging me? 6.5%, from whom I have borrowed 33,000, right? Or I have lent 33,000, right? So if I'm lending someone, I'm lending at 6.5%, right? Keep it simple. I'm borrowing. So 6.5% is my interest, right? Over here. Now 33,000 I borrowed. So it means this 33,000 is available to me to consume, right? So this is 33,000, and when there is no sign, obviously by default it's a plus sign, right? So 33,000 is my present value. Why? Because right at the end of the year 0 means right now, I have I'm able to get this money. Or now at the end of the third period, is there any future value? No. Future value is usually the lump sum values. When you have equal payments, these are annuities, right? So there is 0 future value, and compute the payment. In order to settle this 33,000 loan in 3 equal annual payments over the next 3-year period of time, when the lender is charging me 6.5%, I have to pay 12,460. Minus sign is showing me that I have to pay. At that time, that money will go out of my pocket and will not be available to me to consume, right? So you also have now by this time realized that whenever I put the present value in plus, my payment value will come in negative, and vice versa. If I'll put the present value in negative, my payment values will come in the positive. And in the same way, the relationship go with the present value and the future values. Now this is the amortization table. Remember, this is a very simple example. If you have 36 years over which you have to pay the loan, let's suppose 25 years, and the payment will happen after every 1 month, you needed to have an amortization table to show it to the if you are lending, to show it to the borrower. Or if you are a borrower, obviously you are interested that, let's suppose after 19 payments, what is the amount I will still owe to the lender if I borrowed the money. So in the same way, try to understand this concept, and because you might have to implement it in the Excel, most of these amortization tables need to be built in the Excel. So at the beginning 33,000 you borrowed, right? We already calculated the equal payment. These three equal payments won't change. Now, what is the interest rate? 6.5%. So calculate 6.5% of 33,000. You'll get 2,145. This 2,145 needed to be subtracted from this 12,460. This is 10,301.5. So it means out of 12,460 payment, which happened at the end of the first year, 2,145 was the interest, and rest 10,315 was my principal repayment. So what is now the balance money? My repayment of the principal, which is this one, 10,315 subtracted by 33,000. So this is the remaining balance for the next period, means next year. Over here, the periods are described in terms of yearly basis, right? So 22,685. Now this payment again remains the same. Same payment won't change. What is the interest? 6.5% of 22,685. This is the interest payment, and this needed to be subtracted from 12,460. So you'll get 10,985. So it means this 12,460, the two component which is basically making 12,465 is 1,474.53, which is the interest component of the annuity payment, and 10,985 is the principal repayment. Now subtract this 10,985.48 from 12,685. This is the beginning balance, 11,699.53 for the third year. Now calculate 6.5% on this. You'll get 760.45. So this 760 is a part of this 12,460, and the rest is actually the principal repayment, 11,699.53, and the remaining balance is 0. Now if you see what is happening, that the annuity fixed payment 12,460 is composed of the interest payment and the principal. In the starting years of the loan, because there is a more balance on which you have to pay the interest payment is always more. And as the time goes on, the interest payment will start decreasing. From 2,145, it decreased to 1,474, it further decreased to 760, right? And obviously, because this in annuity payment remains constant, this one, so if the interest payment is getting squeezed down, then the principal payments start getting increased. So this is how we work with the amortization table or amortization schedule, right? We use it, mostly people also use it, the name of amortization schedule. Let's quickly recap what we have learned. We have learned how to conduct the present value calculation of the annuities, both ordinary annuity and the annuity due. We also discussed in detail that what is the difference between the quoted interest rate, we can also say the quoted interest rate as the simple interest rate, and the effective annual rate, right? Interest rate you can say, or effective annual rate, right? EAR. And also we discussed about the amortization schedule and how to conduct the prepare the amortization schedule or table, and also how to do the amortization calculation. And actually over here we can also see that amortization payments are actually annuity payments, where you are repaying the loan. Either you are paying, or someone, if you have lent, then the borrower has to repay the loan over the period of over the life of the loan in equal payments after fixed interval of time. So it's effectively an annuity, right? So that's all. If you have any questions, please comment below, or you can also send me an email if you have my email. Thank you.